Hi everybody, this is going to be a little mini lesson for 1.6 in the 8th grade math section. This is all about exponent rules, and before we look at page 42 and 43, I'm going to have you guys copy some things down in your math notebook. So I want you to have this with you, but then I want you to copy down what you see in black, the exponent rules, and then I'm going to go through each of those exponent rules and talk to you about them. After we do this, then page 42 and 43 will be a lot simpler. So pause this video as you need it. Just write down the words that are, or the letters and equations that are in black here. What you can do then is you can write the rest of it with me as I talk through it. All right, I'm going to start with the first one. This first one, we have a number raised to the power of a times that same number raised to the power of b. And the rule is that if we have that same base number x, we can just add the exponents. So sometimes the exponent rules are a little bit hard to understand until we actually put them into context with numbers. So first of all, in page 42 and 43, you're going to see that this is called the product of powers property. That is, one way to think of it. I definitely remember always learning this as just the product rule growing up. So product rule for exponents is how it's always stuck in my head. But here we go. Let's say that x is 3. That means it's 3 here, it's 3 here. It's always 3 in this example. A is 1 and b is 2. And I just made those numbers up, and I'm using easy numbers here so that, it's easy math for us to figure out. Okay, so let's take a look at this first one. If x is 3 and a is 1 and b is 2, then we have 3 to the first times 3 to the second, which is the same as 3 to the third because we're going to add the exponents if we're multiplying. So this is why it's the product of powers rule, because we're multiplying. If you think about why this works, 3 to the first is just 1 3. 3 squared is multiplying by 3 twice. And so 3 to the first times 3 squared, of course, is going to be 3 to the third because we'd be multiplying by 3 times. So 3 to the third. I also want you to note that the large number here is called the base, and we'll be referring to that as the base number, and we'll be referring to that superscript small number up above as the exponent. All right, so that's the first one. Let's go to the next one. This is the quotient of powers property. And anytime you see the word quotient, you of course know that we're talking about division. I'm using a fraction bar to signify division here. I will most often do that this year. It's just an important way of looking at fractions and division synonymously. All right, so here we have x to the a, that's supposed to be an a, divided by x to the b. And according to our exponent rule, that's going to be equal to x to the a minus b. So it's when this base number is the same, notice we're using an x and an x, same base number, then we would just subtract our exponents. So again, I'm going to use some nice easy numbers here for our math check. And so we have x is equal to 2, a is equal to 4, and b is equal to 3. And so if we do that, then we have 2 to the fourth divided by 2 to the third, which is going to be equal to 2 to the 4 minus 3, or 2 to the first. So we're just subtracting our exponents here. Here's why it works. We have to, of course, look at why it works. So 2 to the fourth, as we know, is 2 times 2 times 2 times 2. Divided by 2 to the third is 2 times 2 times 2. Well, each of these 2's can be canceled out because 2 divided by 2 is 1. So we got rid of that set. 2 divided by 2 is 1. We got rid of that set. 2 divided by 2 is 1. Got rid of that set, and look what we're left with. 2 over 1, which is the same as 2 to the first, because that is an equivalent way of writing 2. All right, the next one, let's look at the powers of power property. This time we're taking our base number and we're raising it to an exponent, and then we're taking that entire answer raised to another power. So it's a power of the power. This is a power of this power. All right, so that's the same as taking our base number and then multiplying our exponents. To see this in practice, we're going to say that x is equal to 3. We'll say a is equal to 5 and b is equal to 2. And of course, I just made these numbers up again. so that we could look at how this works. So now I'm going to do 3 to the 5th, and then that whole thing, 3 to the 5th, to the power of 2. So I'm going to do 3 to the 5th 2 times. So according to this rule, I can just take 5 times 2, and that's going to be equal to 3 to the 5 times 2, or 3 to the 10th. Now to see how that works, of course it works, because 3 to the 5th is 3 times 3 times 3 times 3 times 3. And then when we square a number, we multiply it by itself. So let's multiply 3 times 3 times 3 times 3 times 3 times itself, and we get 3 times 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 3, which is another way of writing 3 to the 10th. All right, the next one, this one's called the product, or the power of product property. You're multiplying your x and your y here. Now we're going to use another base number. So y is an additional base number. So x and y are being multiplied. We know they're being multiplied because see how they're sitting right next to each other. And together, the product of those two numbers, when we multiply them, is raised to an exponent. That's the same, according to our exponent rules, that's the same as taking the x raised to the power of a times the y raised to the power of a. So to substitute in some numbers so you can see how this works, we're going to use 2 for x, 4 for a, and 3 for y. So that means that we have 2 times 3 inside our parentheses, and we're raising it to the power of 4. So we know that 2 times 3 is 6, and so that would be equal to 6 to the power of 4, which would be the same as 2 to the 4th times 3 to the 4th. And let's look and see that that is in fact true. Well, 6 to the 4th we know means 6 times 6 times 6 times 6, which is a pretty big number, 1,296. We know that that's going to be equal to 2 to the 4th times 3 to the 4th. Well, 2 to the 4th is equal to 16, 2 times 2 times 2 times 2. And 3 to the 4th is equal to 81, which is 3 times 3 times 3 times 3. And if you take 16 times 81, you in fact get 1,296. Okay, everybody, the next page, 3 more rules. The power of fraction property, the negative exponent rule, and the zero exponent rule. So 3 more to go. This one we have this fraction, or you could look at it as a division problem, x divided by y, and then that whole thing raised to the power of a. According to our exponent rule, that's the same as x to the a divided by y to the a. And so if we're going to use our easy numbers to be able to see an example, I chose 2 for x, 3 for y, and 4 for a, so that I could make 2/3. So my x is 2, my y is 3, so 2/3, and I'm raising that to the 4th power, which means 2/3 times 2/3 times 2/3 times 2/3, and if I simplify that, I get 2 times 2 times 2 times 2, which is 16, and 3 times 3 times 3 times 3, which is 81. I know that that's equal to what if I would have done instead 2 to the 4th divided by 3 to the 4th. 2 to the 4th is 16, and 3 to the 4th is 81, so of course I get the same answer. All right, the negative exponent rule, this is one that you kind of just have to memorize, you guys. It's a little bit wonky to really wrap our head around the idea of a negative exponent. But once we start working with negative exponents, it will start to make sense as to why we put it underneath 1 in a fraction. And so a base number raised to an exponent that is negative basically moves that base number with the exponent to the denominator of a fraction. It becomes a fractional portion of what we got here. And so let's apply some numbers to this. X, let's say, is 3 and a is 2. And so what we have then is we have 3 raised to the negative 2 power, which according to our exponent rules is the same as 1 over 3 to the 2nd power. And we know that 3 to the 2nd power is the same as 3 times 3, which is 9. And so we know that 3 to the negative 2 power is equal to a 9th. And I think you already know the zero exponent rule. Any number raised to the 0 power is 1. We've talked about this already in class. Remember when we talked about what happens here. Let's actually make x a 10 for this, or a 2. Let's make it a 2 for this example. So 2 to the first, 2 squared, 2 cubed, 2 to the fourth. Well, we know 2 to the first is 2, 2 squared is 4, 2 to the third is 8, and 2 to the fourth is 16. And when we move this direction, we know we're multiplying by 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. But we also know that when we go the other direction, we are dividing by 2. So if I go this way, from 16 to 8, I have to divide by 2. And from 8 to 4, I have to divide by 2. And to get from 4 to 2, I have to divide by 2. So if we were to keep going and add an additional exponent here where we have x to the 0 power, which would be 2 to the 0 power, and we want to see what that's equal to, well, let's figure out what do we multiply, what number multiplied by 2 is 2 to follow our pattern, or in other words, 2 divided by 2 gives us what number? 1. So any number raised to the 0 power is 1. And like I said, I think that part should be a review. Okay, now I know I don't have a lot of time. I try to keep these fairly brief, but this one's getting long. If you go to page 42 and 43, you're going to just read through all of these descriptions of the rules that I just talked about with you. The product of powers property, the power of products property, the power of powers property, and the quotient of powers property. It's a lot, but let's go to some of these triads, okay? Let's do these triads together, and then you should have enough to be able to do some work on your own. So 7 to the third raised to the power of 2. That means we're going to take 7 to the third power 2 times, right? So we end up with, let's go back to our rules here. We're talking about this rule right here, the power of powers property. So we're looking at 7 to the 3 times 2, so that's equal to 7 to the 3 times 2, and 3 times 2 is 6. And so 7 to the third raised to the second power is equal to 7 to the sixth. You do not actually have to solve or simplify what is 7 to the sixth. That's not the point of this. It's just to write an equivalent expression. So 4 to the fifth raised to the third is going to be the same as 4 to the 5 times 3, which is 4 to the 15th. 9 to the fourth times 8 to the fourth is the same as 9 times 8 to the fourth. You notice that their exponent is the same, so an equivalent expression would just be 72, since that's 9 times 8 to the fourth. And then lastly, we have 8 to the ninth divided by 8 to the third, and I'm going to write it like this so you recognize that from the notes that we just took. 8 to the ninth divided by 8 to the third is the same as 8 to the 9 minus 3, or 8 to the sixth. Okay, so you're practicing a bunch of problems with these rules. Make sure that you have your notes nearby because it just takes some practice to start getting used to those exponent rules. All right, everybody, thanks for listening.